Welcome to the event Discovering Tardigrades, Small Yet Strong. Tonight we will have here Arianna Ricchiuti, but before giving her the word, let me introduce very quickly PoliSpace. Hi Arianna.
Hello everyone, ciao ciao.
PoliSpace is a non-profit student organization founded in September 2020, the first completely space-related of Politecnico di Milano. It has three main objectives: offer students hands-on experiences on real space engineering projects, help them building their network in the aerospace sector, and spread their space culture and opportunities. We are internally organized as a small, medium-sized enterprise divided in 5 departments to let the members experience the workflow of a real company. We act as a company, but actually we live as a family. If you like to join the association, you just have to visit our website, polispace.it, and become a member. You will be offered lots of opportunities in the space domain, access to members reserved webinars and discounts on our merchandising and activities. Well, now that you know a bit about PoliSpace, we can go ahead with our guest. Arianna holds a bachelor in biology and a master in science communication and journalism. She's editor of EJR-Quartz for ESA, working at ESA ESTEC Communication Office in the Netherlands, where she is responsible for internal communication and events. Tonight she will talk about tardigrades, microscopic invertebrate animals, which are among the strongest and most versatile creatures on Earth, and live in extreme environments. If you have some questions, you just have to write them in the chat, and Arianna will answer at the end. Okay. Now we will start the discussion. So let's start with talking a bit about your story with tardigrades. Why did you get so passionate about them? How did you find out about them?
Okay, first of all, hello again, everyone. Thank you so much for inviting me, and congratulations to you guys, because you're doing such an amazing job with PoliSpace. So really, bravi, bravi, bravi. And yeah, so my passion with tardigrades started back in when I was in the last year of my bachelor in biology, because when I was there, I had to follow a course in microbiology, and the professor of microbiology was such a passionate person. He was always smiling. He was always really interested in what he was telling us. And one day he mentioned tardigrades, and I just fell in love with them. Really, I fell in love with them, and I simply started to like to study them on my own. I started to do some research, to join some seminars in order to discover more about them. Do you see the clip? They are so badass. Come on, they are so cool. They are so cute. And the cool thing is that people of any age like them, because they are really amazing. And so I did, for example, my bachelor thesis about bacteria and tardigrades as models for alien life. And then there was, when I was for a science seminar, I went to the Azores. And there was the first time that I could actually observe tardigrades through a microscope. And it was really amazing. It was breathtaking. And then if you ever had the chance, I'm based in Leiden near Amsterdam. And in Amsterdam, there's Micropia, which is the only museum in the world completely dedicated to microorganisms. And there they have many samples of tardigrades, and it's an amazing museum. So if you have the chance, come to Micropia and come to Amsterdam, because it's an amazing experience. And yeah, so that's how it went, and that's how we started, basically.
Wow, but what are they, and how were they discovered at first?
Yeah, so I see stopped. Okay. So tardigrades, no, let me go exactly. So tardigrades are, first of all, they are animals, okay? They are not microorganisms, because when we talk about microorganisms, we usually refer to organisms that are made only of one cell, unicellular organisms. They are animals, they are pluricellular organisms, and so they are invertebrate with so no skeleton, and they are metameric, which means if you see this picture, you will see, but also in others that are gonna follow, you will see there are some segments that repeat throughout the body. These are called, forgive me for the pronunciation, I'm not sure, but should be metamers or metameres. And so these are the segments that make the body. And yeah, they live really in every possible environment on our planet. Probably, I'm sure you ate them with a salad and you didn't even realize that, because they really live everywhere, from extreme environments, but also, for example, in a garden of your houses. So they are really in every possible corner of our planet. And so, as you can see, for example, from this first picture, they have a very um, I would say in between, from terrifying to cute mouth and and face. This really resembles the tube of a vacuum cleaner. And so you can see the mouth here in these parts, or sometimes even here, you can see some eye spots. Then you can see there are some paws with nails, and so on. But let's move on to another picture so I can. Oh, yeah, I forgot about this one. This is so cool. So you can see a close-up image of the mouth. Actually, this is not a mouth, of course. It's more a tubular mouth. When you can see there's a sticking and sucking apparatus. So what they do is they protrudere. How do you say protrudere in English? I don't know. So basically, they allungare. You need to help me. They do this with the mouth. So they
put the mouth outside.
Exactly. Thank you so much. They put the mouth outside, which is a tube. They put the tube into their prey, and then they suck their prey, which usually are algae, other tardigrades. So yes, there are some tardigrades that do cannibalism, but can be also rotifers and other microorganisms. And then, of course, they suck the liquids from the prey. And so yeah, that's how they eat. And okay, yeah, that's what I wanted. So here you can see some illustrations of the apparatus that characterize the tardigrades. So if we start from example from the first illustration, structural body parts, so you will see, of course, claw glands. Okay, inside of the body, the inside of tardigrade's body is made, let's say, of water, okay, of liquid, where organelles are suspended, and where there are also muscle fibers that are suspended. You can see them here. And outside, let me just come back for a second. This sort of skin that you see is called a cuticule, and it's made of a sugar that should be pronounced as, I think, chitin or chitin, I'm not sure. By the way, it's really resistant, and it's a very important feature for them in order to survive in extreme environments. And the cuticle gets changed over time with molting. So they change their skin during their lives. And let me come back here. Of course, if you want to interrupt me at some point because there are questions, or you have questions, feel free to do so. There's no problem at all. Then let's enter a little bit more the body, you can see the digestive system. So starting from the mouth, I just mentioned to you that they put their tube out and then they suck the liquids from the prey. This is possible thanks to these two structures that you see over here, the black ones, which are called, I believe, stylets. And so this help the movement for this kind of process. Then you have the buccal tube, which helps to create like a depression that allows the sucking of the prey. Here you can see the pharynx. Then we go down here, we have the salivary glands, very helpful. Then if we go a little bit towards the bottom of the body, they have gut, which is divided into three parts, so anterior, mid, and posterior gut. Then here we can see the structures, which are called Malpighian tubules, which they are like the excretory system of tardigrades. So basically, thanks to the Malpighian tubules, they remove the waste from the body. And then here you can see cloaca, which is a hole that collects both waste from the digestive system, waste from, no, sorry, it's not waste at all. I would say waste from the reproductive system. Well, no, these are sperms or eggs. And yeah, and basically that's it. Then let's move on to the other illustration. Oops.
How do they reproduct? How do they reproduct? How do they?
Okay, let me go on then. Here.
Okay, sorry.
No, wait, just a second. Let's move to the last illustration. Reproductive system. This is such a good question because tardigrades really show a variety of reproductive ways. They are really incredible. So first of all, let me say tardigrades only reproduce thanks to gametes. So the male produces sperms while the female produces eggs, and that's it. But then let's see what we can find here. This is the illustration representing a female. So you can see there's the ovary, there's with the eggs, of course. Then there's the so-called spermatheca, because usually the male can make a hole in the cuticle of the female and inject spermatozoa in there, and so the spermatheca is useful to collect them, and then of course a cloaca. But let me go to the last one.
So there are male and female.
Exactly, but we have to separate because we said the tardigrades live in every environment, okay? So this means both in marine environments, but also in terrestrial environments. And so marine species reproduce by amphimixis. Amphimixis is the union of an egg and of a spermatozoon, and this usually occurs, or as I said before, so the male makes a hole in the cuticle and injects the sperms, or this happens as you can see here. So here you can see this is the cuticle which has been released into the water, and into the cuticle you can see 4 eggs. So what happens is that the male releases the sperms into the water, and then the female releases the cuticle with the eggs. And so the union happens in the water. This is another way. These are very beautiful pictures. Can I show a video? I think so. Let's try. Let me try. But I have it there. Let me just move this window over here. Exactly. Can you see it?
Yes.
Okay, I'm gonna put play. So look at that. This is so cool.
Wow.
Okay, you are looking at a female tardigrade which is doing molting, and it's also releasing the eggs into the water. And eggs usually hatch after a couple of weeks after being released. And so yes, this is how they reproduce. Sorry, then I forgot to mention, let me put the full screen. Okay, I forgot to mention about the terrestrial species, because terrestrial species usually reproduce by a method that is called the parthenogenesis. So what happens is that the female produces some eggs that are actually like clones. So these eggs don't need a partner in order to grow. Okay, and if you think about it, this is such a useful evolutionary process, because if we have an egg that can just, it can be transported by the wind, or it can just attach to the hair of some animals and land on a suitable surface, and it can hatch without the need of a sperm and so of a male, you can see how useful this process is, because you don't need to find a partner and you can grow wherever you found a suitable surface or substrate. And so, of course, this is very helpful on one side, but if you think about it, on the other side, there's less genetical variability, because, of course,
Yes.
two partners there are no partners, and so the only mutations that you can have and variability you can have occur just because there are mutational events inside the egg, and that's it. Then let me think, because it's a variety of reproductions. Yes, of course, there are some species which are do you say hermaphrodite, or I'm not sure about the pronunciation, sorry. But so there are some species where a single organism has both the female reproductive system and also the male reproductive system.
Yes.
So you can see how many ways they have in order to reproduce. And again, this is a way, from this you can understand how versatile they are, and also so the reproduction helps them to colonize many different environments. So yeah.
So do they live just on Earth or also in space, right?
Well, as far as we know, they just live on Earth, but I'm very confident that they could be found also on other planets, because they are very, very resistant to many different conditions. And let me go, where should I go? Here. They are really resistant to many environmental conditions, and they have also been tested in outer space. So what they do is that, okay, there are many different, until now, I guess you have understood, you have like spot already some characteristics, some features that make them resistant, okay? But the most important one is a real survival strategy that is called cryptobiosis, as you can read on top here. Cryptobiosis, if you think about the name, if you reflect for a while on the name, this is so cool because it means hidden life. So what they do when there are extreme environmental conditions is that they hide from these environmental conditions. It's such an elegant concept if you think about it. So cryptobiosis is a survival strategy that occurs because there's a problem in the environment. So you need an exogenous stimulus. It's not endogenous, okay? Cryptobiosis starts when the danger in the environment starts. And so what they do is, here at the left, you have a tardigrade in active state, and on the right side, you have a tardigrade in anhydrobiotic state or cryptobiotic state. So what they do is that they start to slow down their metabolism. So they start to slowly, they suspend their movement, their nutrition, and also their breathing, I guess. And so they suspend all their physiological functions, and they enter this state that you can see here at the bottom in more close up. Oh, wow, these are such an amazing, wow, I love these pictures. Look at them. They enter this state that is called a TAN, or dehydrated state, where they are just between life and death, really. They just stay there, they hide from the danger in the environment, just waiting that the environmental conditions come back as to normal. So
for how long can they stay in this state?
It has been tested upon 30 years. There was, I'm sorry to say that, but there was a fake news running in the internet some years ago that stated that they can survive in cryptobiosis for up to 1 century. Guys, this has never been tested, has never been proved. It's an hypothesis, of course, a very interesting hypothesis, I would say, but by now we don't know that. We know that they can survive in cryptobiosis for decades. Yeah. And what they do also, of course, they need to suspend their metabolism. So the most important substance to every metabolism is water. So in order to suspend the metabolism, you have to get rid of your water. And so that's, you can see this clearly on the right picture. So they become really dehydrated, really dry, and they lose the water up to 95%, which is really a lot. And so they just wait for better conditions to come. It's really an amazing process, I believe. And
Yes.
let me show you, I have a video also here. But let me do this because I already have it here. Exactly. So this is the wonder of anhydrobiosis or cryptobiosis. Can you see that? Can you confirm?
Yes.
Okay. So as you can see, they start to slow down their metabolism. They retract their pores and they become like a ton, like a very little balls. And in this state, they are between life and death. It's a completely ametabolic state. And they can survive up to decades. Then, if you give them some water, this is all they need. They start to open again, to put their paws outside. They start to move. And so they come back into the active state. This is such breathtaking, I believe. I love that. Moss piglets, of course, they are also called the moss piglets or water bears. You will hear these words pretty much all over the
They are so cool.
Mm-hmm. Yeah.
Which are the predators? Which are the predators of these organisms?
Sorry, can you repeat?
Yes, which are the predators of the...
Sure. They have many different predators that range from arthropods, so spiders, insects, other tardigrades, of course. Then there are some, do you say worms, vermi? Yeah, I think so, worms, and so on. So there are many species who can eat tardigrades.
I would like to ask you about the famous experiment that was done in space. If you like to talk about it.
Of course. So yeah, because we mentioned that in when they are in extreme conditions, which of course are also space conditions, they enter this cryptobiotic state in order to survive. And so this was clearly observed when there was when the European Space Agency decided to send a bunch of tardigrades in space. And so what they, let's put this one, which is really nice. So what they did, they actually sent a few thousand of tardigrades in space on a capsule, which is called the photon capsule, which orbited around our planet for around 12 days. And so there were two sets of experiments. In the first one, there were tardigrades inside the capsule, and in the second one, there were tardigrades outside the capsule. So in the experiment that was inside the photon capsule, there were both active tardigrades and dehydrated tardigrades. Instead, in the experiment outside, only dry tardigrades. You can understand, right? Outside the capsule, you are subjected to much more stresses than, of course, inside the capsule, where you are a little bit protected by the shield and by the vehicle itself. So regarding the ones that were inside, it was observed that the survival rate was up to 60% for the active tardigrades and up to 94% for the dry tardigrades, which is really a lot. And also what they did was observing them, of course, for the whole mission, and they saw that the active ones were even able to reproduce in space. Okay, so they were able to reproduce, to produce eggs, and the even coolest thing is that when they were brought back to Earth after 12 days, what they saw is that the eggs could actually hatch and give birth to a second generation of fully operational and cool tardigrades. So can you see how they are capable of surviving extreme conditions? They were even able to reproduce and to produce offspring, which was completely normal. Okay. Instead, if we have a look at the ones that were outside the spacecraft, that's a different thing, because outside the spacecraft, you have vacuum, you have radiation, you have, of course, very low temperatures and many other stresses. So the survival rate was much more lower, and there was no chance to reproduce, of course, because they were in a dry state, and in the dry state, you can do anything.
Yes.
So yeah, but they were, now that I remember, they also, of course, there were ground controls during the mission, and what they saw is that the eggs that were dried outside the spacecraft could survive a little bit better compared to not the eggs, but the adult tardigrades. So this is a very curious thing.
Okay, wow.
Yeah, it's a wonderful world, right? There are so many things to learn and to understand. Yeah.
So let's see if we have some questions from the chat. Okay. So how fast can they hibernate? Nicola Pascolo Fiore asks.
That's a good question, because thanks to all that I said, you may think, okay, cool, so they can survive whatever, it doesn't matter, they are superheroes. And I actually describe them as superheroes when I'm talking to kids, but this is not completely true, okay? Because to enter and to exit the cryptobiosis, you need from 30 minutes to 48 hours, depending on the species. So think about it. If you put a tardigrade suddenly at, I don't know, 200 degrees below zero, this is gonna die, okay? Because they need time to acclimate, they need time to enter cryptobiosis, to adapt, and to enter this state where they are able to survive. Same thing, of course, because when they have to exit the cryptobiosis, they need time.
So we have other questions. This one is interesting. Are there plans to send them for another space mission?
Actually, I would be very happy to see them again on a new mission, but no, at the moment, as far as I know, there are no mission foreseen. But now that I remember, guys, I'm sure you read about it on the internet. 2 years ago, the come si dice? Israelian in the space industry sent a lander to the moon, the Bereshit lander, and inside the lander there were some tardigrade samples. And if you remember, the Bereshit lander was, of course, supposed to land safely on the moon, but instead there were some problems and it crashed onto the moon. And so what we know is that, of course, now actually there are tardigrades on the moon. We don't know if they are alive. We don't know anything because, of course, the lander crashed, so there was no chance to monitor them after the landing. But I'm pretty sure they are doing well on the moon. I'm sure they are all dry. It's very likely they are all dry because, of course, on the moon you have many differences in temperature from the areas where there's the sun and the areas where it's all dark. So, but I'm pretty confident that they are doing well on the moon.
Now we have some other questions. Francesco asks, by chance, was it discovered how the eggs and the organisms had been affected by the radiative environment?
Yes, good point. So let's come back for a while to, please leave me the question so I can then go back to the point. Let's go back for a while to the cryptobiotic state. So we're here, right? I told you they have to get rid of the water. But if you think about it, we learned this since we are kids. Water is the essential constituent of every living being on Earth and probably in the universe. Water is essential. You can live without water and so on. So removing water from the organism is like, how can I say this? It's like removing the scaffolding of a building, right? So this maybe doesn't make a lot of sense looking at this just like this, but the reason is removing water is a preventive measure, because if the danger that they have to face in the environment is freezing, maybe you know this better than I do. Water, when freezes, tends to expand, and if the water inside the cells expands, it can actually break the cell membranes. And guys, this is absolutely impossible. This is not possible to survive. So that's why they get rid of water. It's just a preventive measure in order to avoid the breakout of the cells. And what they do instead is that they produce some substances. And then, Francesco, I come to your point. They produce some substances that act as a bioglass in order to fill the cells and to protect the membranes and the DNA. So there are two substances. The first one is called, I believe, triallose, which is a sugar. And the other one, these are called intrinsically disordered proteins. And both these two substances act as a bioglass that fills the cells and keeps them safe. The other point is that they produce, and this was observed in the eggs and in the organisms subjected to radiation. They produce the heat shock proteins, which help them to survive when they are hit by radiation, and also a very cool and exclusive protein, which is called the damage suppressor. And this protein, we don't know the existence of this protein in any other organism on our planet. So this is pretty cool. And the damage suppressor helps the tardigrades not to feel the pain when they are subjected to many environmental stresses. And it's also involved in the radiation stress. So as you can see, they show so many ways, so many substances and features that can help them to survive in extreme conditions.
Okay, thank you. We have the last question.
Yes. Oh, right. How do they breathe? We talked about the digestive system and whatever. They simply breathe through their skin. Okay, the cuticle is very resistant, but it also allows the exchange of water and oxygen and CO2 with the environment. So yeah, they breathe through the skin, basically.
Okay, thank you. We don't have other questions. If you like to talk about something else.
Let me think, because here I see, for example, the nervous system. So yeah, they have a nervous system, which is very easy, very primitive. So you have a nerve cord in here, simple eye. They are also called eye spots, but not every species has eye spots. Some species don't have eyes at all. And there in the head, you can see a brain, which of course is not like our brain at all. It's a very primitive one, and it's more like a group of neurons all together. They are called ganglia. Maybe you heard this word before. The species who don't have eye spots, maybe you've seen some pictures. I don't have them there, but maybe you've seen some pictures of tardigrades which have kind of some, how can I call them? Do you say filaments in English? They have some filaments.
I don't know.
Filamenti. The Italian guys over there, please help me. Filamenti. How do you say filamenti in English? Fili. Pile. Probably.
I don't know.
Let me search for it. We have time. There's no problem, right? We are among friends. I can search for it. Filamento. Non mi viene proprio. Filamento.
There are other two questions. Then they just arrived.
A fiber or filament or filament, I don't know, but yes. And so these are some structures that they use in order to perceive the changes in the environment if they don't have eye spots. Strings, thank you.
So this guy asks, how smart are they? If they reflexes.
How smart are they? We should define what does it mean to be smart first, I think. I don't know. Do they have trained reflexes? What do you mean by trained reflexes, Nicola? If you can type it in Italian, I can understand better. Because reflexes, yes, of course, they have them. Yeah.
I wait if he answers.
I see another question then.
Yeah. So we have this one. So maybe we can ask. Okay.
How do they breathe in space? Yeah.
Yeah.
That they learn from experience. Well, Nicola, I need to be honest with you. I don't know this answer. But this is really a good question. Conditional reflexes that they learn from experience. I would tend to say no, but the most honest answer I can give you is that I don't know.
Okay.
I think also, honestly, I don't think there have ever been studies focusing on this part. But maybe you can do that one day if you like it.
So let's go back to Francesco one.
So if they are in the dry state, of course they don't breathe. So there's no problem in here. Inside the capsule, you can recreate the aerobic environment, put in oxygen, and so they were breathing oxygen. Of course, always the active ones and not the dry ones.
I like this question.
Are they social animals? Yes, they tend to live in groups. They tend to mate, of course, if they are not if they don't do the self-fertilization. And yes, you will never find one tardigrade. You will always find groups of tardigrades living together. Yes, definitely, and they interact with each other, of course.
Okay, so we have this question then. Do you think one day it will be possible to use this special preservation liquid for humans to enter cryosleep like you see in sci-fi movies?
Absolutely, yes, Julian. And I can tell you more. Cryptobiosis is a very interesting process, and not only because I believe it's breathtaking just because of the biological side, just because it is amazing. But also because it can be exploited, for example, to preserve better organs, vaccines, and also to improve the sunscreen, the sun creams that we use, and so there are many different applications. Well, yours is a pretty interesting one, but I'm sure we can take inspiration from them. Yes.
Oh. Okay.
I'm reading all the comments and I see strings, threads, filaments. Thank you guys. Thank you for all the suggestions.
We have another question from Nicola.
So they could live well in an isolated biosphere jar orbiting the Earth? Well, I guess so. Absolutely. Yeah. I would be not surprised if we would find them somewhere else in the universe. Absolutely. And when I told you before that the cryptobiosis lasts decades, but it's not clear. And I mean, at the moment, it's not true that it can last for 100 years or more. This is a very important point because, as some of you may know, there's a theory in the astrobiological community called panspermia. Panspermia is the theory that states that some microorganisms like bacteria, tardigrades, and so on, and also some biological molecules could spread all over the universe from one planet to another thanks to rocky bodies, so basically comets and asteroids. This is such an amazing theory, and it's very inspiring, but moving from a planet to another takes years or even billions of years. So we have to set our expectations, because at the moment we can say, hey, okay, a tardigrade has come on our planet from I don't know, another one that is billions of light years away from ours.
So I think you already said this, but if you like to.
No, not yet. Not yet. Let's say not yet, but maybe in the future, I'm sure. And I really hope there's gonna be more experiments about tardigrades in the outer space. Maybe testing them for long duration missions and not only 12 days. This would be a great challenge, I believe, for their understanding.
What is the aspect that you like most about tardigrades?
Well, everything. Can I say everything? No, but what I like is that they are. I mean, I like their. You see, their appearance. I would say they are cute. So when you look at them, you feel like, oh, they're so cute. Like when you look at a cat or a kitten. Okay, so I like that they are funny, because this, especially with kids, this helps a lot, the narration and the communication that you can do towards them. It's not, of course, if I'm going to a kid and I'm saying, hey, look at this, is a wonderful spider or tarantula, okay, this is a completely different effect, right? Instead, if I go to a kid and say, hey, these are tardigrades, they are like, oh, they're so cute, even though some are terrified by their face. But yeah, I would say the most interesting aspect is absolutely the cryptobiosis, because at the moment we don't know yet all the limits that they can push thanks to this mechanism. For example, we know they can survive 6 years at 80 degrees Celsius, of course, under zero. We know that they can survive 20 months at minus 200 and 20 hours at minus 272, which is really a lot. Minus 272 is just 1 point above the lowest temperature possible in the universe. So this is pretty awesome. And also we know that they can, where is it? Here, look at this right image on the right bottom. They can survive also up to 150 degree above zero, and this is much higher than the temperature at which water boils. So this is pretty amazing and astonishing. So we know some limits, because of course this is what we have studied, but it would be pretty awesome to push these limits and to see how far they can go. This is the most amazing aspect, I would say.
Francesco asks if it is possible for them to live on the surface of different planets from Earth.
I would say no. I would say maybe they could stand if there's water, of course. If they are like in a pond, they could stand if they are under the surface, because they are shielded from the radiation, which is really dangerous to them. This is an interesting point. What we have seen is that high temperatures might be their weakness, because there have been different studies focusing on high temperatures and the combination of high temperatures and radiations. And what we have seen is that the long exposure to high temperatures is really their weakness. The longer the exposure, the lower their chance to survive. So I'm sorry to say this, but if our planet is gonna get too much hot in the future, we won't be the only ones suffering, but also tardigrades at some point. They are not invincible, okay? They have their own limits.
Okay, I like also this one.
Okay, I see.
This is interesting.
Would you like to advise us on how to reach the goal of working at TISA? First point, very basic point, but it's really all you need. Get a certification of a C1 advanced level of English. This is the most important point. If you know the language very well, so which means speaking, maybe also better than me, okay? But speaking, reading, writing, and of course listening, because when you work at TISA, you have to listen from people coming from all over the world, which means listening to different accents and pronunciations of every possible word. If you know this, you can work at TISA. I would say this. But of course, many of you, I guess, are engineers or physicists and so on. And maybe many of you are between the bachelor and the master degree. So what you can do, of course, is to go on the ESA website and to look for internships. If you do an internship during your master, you're gonna get hired. I would say afterwards. This is what I did. This is what many people of my age did. I did an internship at TISA in communication, of course, and then I found this position last July. So then, of course, I would say find your path, understand what you like, the subject that you want to study, where do you want to end up. Always ask for help. This is a thing that I always done in my life, and it's so useful. Never be afraid to ask for help to anyone, and also try to enrich your CV with experiences that might be helpful for your goal. So what I mean is, when I applied for this position, I didn't have just a bachelor and a master, and that's it. I had a bachelor, a master, 10 science seminars, Italian science festivals. I have some little awards. I had some training courses. So my CV was pretty rich. So this is really an advice. Try to enrich your CV with interesting experiences.
Okay, thank you.
Let me see if I skip some images, but I think we saw most everything. Yes, totally. Let me put this one again, which is very nice.
Okay, so if we don't have other questions, thank you so much for the webinar and for your passion.
Thank you to you. It was really nice. I hope you enjoyed it. I hope my my speaking was pretty understandable.
Yes, it was.
I speak English all day long, so this is absolutely not a problem to me. But this is the first time I was holding a webinar about tardigrades in English. So,
yes, you said.
Thank you, guys. Grazie.
Thank you so much, and thank you all of you for watching us.